Millions of different chemical compounds are known. All of them are built from simpler substances called elements. Elements combine in countless ways, creating the millions of materials that fill our universe. Elements, substances composed of only one kind of atom, are the fundamental building blocks of matter. They combine to form chemical compounds, just as the letters of the alphabet can be combined to form words. The science of chemistry describes the behavior of substances as they undergo physical and chemical changes. Over 100 elements have been discovered. Each has a unique set of physical properties, like density and melting point, and each behaves a certain way in chemical reactions. But which elements will combine, and how? For centuries, scientists have asked these questions, theorizing and looking for patterns. From a mountain of data, chemists began to seek some unifying principle that would explain why different elements had different properties and different behaviors. The result? The periodic table, an enormously useful tool that scientists could use to discover, learn, and remember properties of the elements. The periodic table can be used to recognize similarities and differences among the chemical elements. It can be used to identify the metals and nonmetals, as well as elements with characteristics of both: platinum, silicon, tungsten, lead. These and the other elements each have their own symbol and their own place on the periodic table. If you know an element's position on the periodic table, you can determine many of its chemical and physical properties. You can predict the relative size of its atoms and know how it will react with other elements. It's the periodic recurrence of properties that gives the table its name. One of the first periodic tables was organized in 1869 by a scientist named Dmitri Mendeleev. He used cards to organize what he knew about the elements and came upon a grouping that shed light on other factors. Elements that fall in the same vertical column on the table have similar but not identical properties. These vertical columns are known as a group or family of elements. Metals, gases, transition elements, and rare earths each found themselves in groups when arranged by mass on the earliest versions of the table. Even undiscovered elements were identified by empty spaces in the chart. Later, when others arranged the elements according to atomic number, the grouping improved, and this is what's used today. And this, and this. Some elements are separated from the body of the table. This is really just for printing purposes because the table would be awfully wide if they were left in their proper places.